Hi, Jason. How are you?
8.1.
Okay, we can do that. I think I pulled the slides down as well. Let me check. Let me take a look. Well, I did, but that doesn't mean I opened it, does it? Let's take a look. So 8.1 is getting us into the hypothesis testing for the traditional method. It's not that long, and it's mostly comprehension questions that you're going to need for later on in the chapter. So these sections, so I'm going to take some time and go over some of this. Let me open up the screen here and make sure that I'm sharing the screen and putting on the subtitles because let's see, caption, where's my, there it is. How was your weekend?
Good.
Good. Okay. Let's see if we can. Almost there. Let's see. All right. So the first part of this, let me share this screen with us instead of the, okay. There. You should be able to see it. Whoops.
I
I
see
don't
it.
think that was, yeah, but that's the, is that the homework or the, let me move it over here. I think it's the, how about now?
Yes.
Okay. So a hypothesis is an assumption that we have when we do some kind of research. Maybe it's medical research, maybe it's sports research, and we have two kinds. We have a null and an alternative hypothesis. So if we go, it says define the null and the alternative hypotheses and give an example of each. Well, okay. So if we go to the notes over here, we can see that we're gonna, so it's a decision-making process for evaluating claims about a population, and she gives you all the sub-steps in here. We're gonna get into that when we start doing it. There are three methods used to test hypotheses: the traditional method, the p-value method, and the confidence interval method. We're gonna work on the traditional method for quite a while, and then we're gonna go into the p-value method. The confidence interval method is available. She doesn't really place a lot of emphasis on it, but she wants you to know that it's there. So we have two kinds of hypotheses. This is your null. This is the definition. The null hypothesis, H sub 0, is the neutral, non-controversial statement about a population parameter. HO often represents no difference, no change, or no effect. So this is something that we go into the research believing already. This is what we go into the research thinking. So when you define the null hypothesis, where it says define, whoops, didn't mean to do that, sorry. Where it says define the null hypothesis, you can write the whole first square on this slide. It's the neutral, non-controversial statement about a population parameter. Okay. She gives you some examples below of what that looks like. Now, these are in symbols, but usually we find them in statements. So after you've so let me show you something here. I'm gonna stop sharing this for a minute, just so we can see what this looks like. I'm gonna pull up. Is it gonna show me? Okay, hold on. 8.2. This one here. Okay. This is not what I wanted. Okay, no. No, that's not it. What I wanted to show you was, hold on. I want to skip ahead for a minute just to show you this. So you can see what this looks like in practice. I'm gonna show you. Share screen. I'm gonna go to 8.0. If I go to 8.2 really quick, let me show you so here's what this looks like. We're not doing this today in this lesson, but just so you can see this. A maker of frozen meals claims that the average calorie content of its meals is 800. This statement here, this statement in red, claims that the average caloric content of its meals is 800. That's a hypothesis. That's a hypothesis. The average calorie content of its meals is 800. And because of this that means equal. And for reasons that we're going to talk about in a minute, this hypothesis that you see boxed or bracketed in black is what we call the null hypothesis. So the average calorie content of a meal is 800. That's an example of a hypothesis. Okay.
Oh, so a null hypothesis or a
That's an example of a null hypothesis. Yeah.
okay, but I can't put that.
You can put that. You can make any statement you want. As like, it doesn't have to be so it's any conjecture that you want. Like, I think that students who study online get better grades than students who study in the classroom. That would be an example of an alternative hypothesis. Okay. Any kind of claim that you want about just about anything, you can turn into, as long as you can actually test it somehow. Yeah,
Okay.
you couldn't make a claim and say, for example, I think, Sam Spade is a jerk. That's not but you could say, I believe that a majority of people believe that Sam Spade is a jerk, and that then you could, as long as you can actually test it, it has to be a testable statement of some kind.
Okay.
Okay.
So I could put that then?
You can use, well, okay, let me ask you this. I mean, this isn't meant to be hard. So you can actually use any of, let me go back to the other one, just because I wanted you to see how this looks. These are all examples of null hypotheses. So for example, you could say 4 out of 5 dentists agree what? What do they agree about? What would you say?
Four out of five dentists agree. I don't know.
Well, what would a dentist care about?
Hygiene.
Okay, so 4 out of 5 dentists agree that. What would they say about hygiene? What would they say?
Hygiene. Hygiene. Hygiene must be. I don't know.
You're on the right track. That hygiene, let's say hygiene is important to dental health, something like that, right?
Oh yeah, hygiene
So
is
you could
important to
say
dental.
for your null hypothesis, you could say that you could write it as something like this. So you could say, here's your null hypothesis example, right? Null hypothesis example. You could say 4 out of 5 dentists agree that hygiene, let's put oral hygiene, right? Oral hygiene, because that's what they're focused on, is important, right? For health. That works. That's a null hypothesis example, right? And the reason that it's a null hypothesis, we're going to get into this more later as we go through it, but here it's making a statement about the exact number or the exact percentage, 4 out of 5 dentists. That's a null hypothesis. When it includes the number itself or the percentage itself, it's the null. Okay. All right, let's define the alternative hypothesis. So the alternative hypothesis here, let's scroll down to the next statement. Here's H1 or HA, okay? The reason she has both symbols is in our class, we're going to use H1, but some people have seen it with HA. So here's your definition of alternative hypothesis, okay? The alternative hypothesis, H1 or HA, is the research hypothesis. It is usually a statement about the value of a parameter that we hope to demonstrate is true. So it's not the one that we already believe. It's the one that we want to show is true. It's the one we're actually testing to see if it's changed or not. So this is your definition of an alternative hypothesis, okay?
Okay, got it.
All right. So now if you look down here, the alternative hypothesis is not equal to, greater than, or less than. So it's not going to have an equal. It's going to have a not equal, a greater than, or less than. So if you wanted to go back to your example here about the dentists, right? I could write several alternative hypotheses out of this, but one that I could write would be to say this: alternative hypothesis example, okay? And it's going to look very similar, but I'm going to have to tweak a little bit of the wording in the front. So I could say more than 4 out of 5, more than 4 out of 5 dentists agree that oral hygiene is important for health. That becomes an alternative hypothesis, because now it's more than. So now this statement, and again, when we start doing the hypotheses in 8.2, this will make more sense. But this right now is a proportion, and it's more than 4 out of 5. So P is greater than 4 out of 5, which is 80%. That's why this is an alternative hypothesis. Okay, this is more than 80%. Because again, 4 out of 5, if I convert that to a decimal, is 80%. We normally would do that. So that would be an example of an alternative hypothesis. Okay.
Mhm.
Now, so the first step that we always do is we write or we identify these hypotheses. Okay, that's the first thing that we do. The next question on this list, let me find the homework here. Let me see. Okay, let me stop sharing and go back to the homework, because I think I might have closed it. Let me check. Got a lot of screens. Where did it go? Well, that's all right. Well, no problem. So the second question says, what is meant, and I'll share the screen in a minute. It says, what is meant by a statistical test? In other words, we're defining what a statistical test is. This is what the null and the alternative hypotheses are for. We're testing something, right? So let's look at the notes and see what a statistical test means. So we're going to go here. And it says, go over here. Okay. When you do a statistical test, okay, she doesn't specifically give you, let me see. Okay, this is a statistical hypothesis. So a statistical test is going to be, it's a procedure that you test hypotheses with. That's what a statistical test is. So a statistical test, let me put it on the whiteboard. The statistical test or a hypothesis test. Okay. A statistical, oops. I guess I should capitalize this, right? A statistical test is a procedure for deciding, and this is my own words, okay, not the book. It's a procedure for deciding whether or not there is evidence to support a hypothesis. That's what a statistical test is. It is a procedure that you go through, and we're going to be talking about the steps in that procedure, but that's what it is. It's the procedure that you go through. She didn't ask you for the elements of a statistical test just yet, just the definition. So it's a procedure for deciding whether or not there's evidence to support a hypothesis that we're trying to figure out. Now, what is meant by a critical region? We have that on the what she has here. Let me show you for she makes this a little more explicit on the answer key, but it says a statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. That's what a statistical test does, but this test is a procedure itself. It does that. Okay. We're using sample data to make a decision about the population. So the critical region now here, this is where when we do this, okay, when we do a statistical test, one of the steps that we do is we compute what's called a test statistic. Okay. And so we're going to skip. Okay. Here's your, okay. So here's the statistical test. She used that. This tells you what it does. It doesn't really add anything onto that. But whether or not there's evidence to support that. Now, when you're dealing with this, we have what we call a critical region and a non-critical region, or a rejection region and a non-rejection region. So here is the definition of a critical region. It's the set of values that lead to the rejection of the null hypothesis. This looks like it is a region. What she meant to say here was it is the alpha region, because we're going to have a and we've seen it before when we do confidence intervals and we have alpha. This is my alpha region. This will be given to you. So the critical region is the region that tells us that there is a difference and it leads to the rejection of the null hypothesis. So I would say this. I would say that the critical region is a range of values that lead to the rejection of the null hypothesis, because the values are significantly different from those that are expected. So you go in with something that you expect to have happen. And you know that your sample, you know that your sample is not going to look exactly like your population looks. Okay. But you're only willing to accept so much difference. And when you get to the critical region, you've gone past the amount of difference that you are willing to accept. And so you reject the null. Okay. Now, the opposite of that is the non-critical region, or the non-rejection region. So the non-critical region is a range of values that that do not lead to rejection of the null hypothesis, because the values are not significantly different. And I should, not significantly different from those that are expected. So it falls into the interval of values that we're willing to accept as reasonable variation. And as I said, this will make more sense when we actually start doing the hypothesis test. Okay. So let me show you the next part. Yeah. And you can see she labeled, let me pull up the screen. So if you look, this is a diagram of a general hypothesis test. Now, we have three kinds. We have a left tail, a right tail, and a two tail. This particular example is a left tail test. So here she's drawn for you in general what this looks like. We have a distribution. We have a critical value on the left, negative, because it's normal. So give me a minute. This is.
I can't hear you. You're breaking up.
Can you hear me?
Yes.
Okay, you can hear me now?
Yeah.
All right, let me see. Your question was about number 4?
Yeah.
What symbols are used to represent the probabilities of type 1 and type 2 errors? Okay. No, I haven't. This is actually for, this is going, this relates to 3 and 5. The one tail versus the two tail. But let me go back to number 4 and show you that. Hold on. This is, okay, whoops. Let me go to the slides so I can show you this. I think she talked about that in, let me take a look, because I think, okay, she's, that number 4 is on slide 16. A type 1 error occurs if one rejects a true null hypothesis. That symbol is alpha. It looks like A, but it's the Greek letter alpha. So the symbol for a type 1 error is alpha. Okay.
Okay.
The symbol for a type 2 error is beta. It looks like a B, but it's a little more fancy. Okay. And what you do when you have a type 2 error is you have the null hypothesis and it's false, but you keep it anyway. That's a type 2 error. Like I said, this will make more sense when we actually start doing the hypothesis test. But right now we're just trying to get used to some of the terminology. Okay.
Mm-hmm.
Okay, so that's number 4. Number 5 is about one tail versus two tail, I believe, right? Yeah, when should a one tail test be used? And when should a two tail test be used? Okay, so let me show you what this looks like before we discuss this. So here, this is a drawing of what a one tail test might look like. This is a left tail test, okay? And it shows you, here's your critical region. Here's the non-critical region, okay?
That's a one tail?
It's considered one tail because there's one critical value here, okay? What we're doing here, if you notice, like we have some kind of hypothesis that mu is greater than or equal to, say, 20, right? And the alternative would be mu is less than 20. So that's my tail, my left tail. This is a one tail test.
Mm-hmm.
Okay. We can have a one tail test on the left, or we can have a one tail test on the right. But whether it's on the left or on the right, we only have one critical value. See that? One critical value. If it's right-tailed, we have a positive critical value. If it's left-tailed, we have a negative critical value.
Mm-hmm.
If we have a two-tailed test, then we have two critical values. They're usually opposites of each other if the distribution is symmetric, okay? There's an exception to that when we get to chi-squared, but that won't be right away. Initially, we're going to do the z distribution, the t distribution, and then the distribution for proportion. So this will hold for a while. But the question is, when do you use a one-tail versus a two-tail test? And what happens here, let me stop sharing this part because she didn't give you the notion behind it. So let me give it to you. A one-tail test, let me go to this whiteboard. We use a one-tail test if we have a good idea of the direction that the sample data fall. In other words, as you remember your hypothesis from earlier, that 4 out of 5 dentists are concerned about oral health, and they say that seeing your dentist is good for oral health, right? We're pretty sure that most dentists would agree with that. So we can pretty safely go with a one-tail test there. We don't have to, but we can. And usually we use a one-tail test if we have a good idea of the direction that the sample data will fall. We could be wrong, so then it might mess up our test, but one-tailed tests are less conservative. So they're more risky because, again, you want to have a pretty good idea. They're less conservative than two-tailed ones. Now, you can always use a two-tailed test. But the book will tell you which one the researchers used, and you should state your hypotheses based on what the book is. But if you were designing a statistical experiment, you're always free to use a two-tailed test. A two-tailed tests are good if a researcher isn't sure which direction the sample data fall, or if the researcher wants to be more conservative in the approach. So if you want to take in more data and you want to be more conservative about it, if it's an exploratory study or something like that, then you use a two-tailed test for that. Two-tailed tests are always appropriate, but you won't always see them done. But that's essentially why that works. Okay. Now, just to show you here, let's see, not this. Let me go back to, oh no, that's not what I wanted to do. First, let me get, I did want to do that, but first I have to get the homework. All right, so problem 6, we're actually going to practice finding critical value or values, okay? This is just like what we did in chapter 6, okay? But with different words. So we've done it before, without knowing it. Find the critical value or values for each. Alpha equals 0.05, but it's 2 tails, okay? Now, she left you instructions on the slides. They're also in the handout that I think she puts with the next lesson when we start talking about it, but she has it on the slides as well. So let me go to that and show you that. So if you're finding critical values, if you look at slide 25 and 26, okay? It gives you a left tail test. You use inverse norm of alpha if it's a left tail. If it's a right tail, use inverse norm 1 minus alpha.
Mhm.
And if you have a two-tailed test, then you need to calculate 2 of them. Inverse norm alpha over 2. So we have to split the alpha. And inverse norm 1 minus.
Are you showing the calculator?
Not yet, but I will. Right now I'm showing the instructions.
Oh, I don't see the instructions. I just see the.
You're not seeing? Okay, thank you for telling me, Jason. What I was showing you was these 2 slides. For your critical values in the next couple of sections, you're going to use these instructions. Can you see it?
Yes.
Okay, if it's a left tail test, your critical value is inverse norm of alpha. If it's a right tail test, it's the critical value is the inverse norm of 1 minus alpha. And if it's a two-tail test, then you have 2 values. One is the inverse norm of alpha divided by 2. And one is the inverse norm of 1 minus alpha over 2. We're gonna do some examples right now so you can practice it, okay? But these are where you find it, slide 25 and 26. There's also a handout, which I think that goes with the next lesson, where she gives you all of the critical value instructions, okay? For all the tests that we're gonna be doing. But let's go back to the homework here. It says find the critical value or values for each. So 6A says alpha is 0.05 and it's 2 tails. So here, this is what this looks like. We have the text. I'm gonna write alpha is 0.05. 0.05, and it's 2 tails. Okay, so what this looks like is this. You've got a distribution. You've got this region. So you've got a tail here. You've got a tail there. Alpha is the total tail area, okay? Since this is 2 tails, you're gonna split this alpha. So you're gonna split this up. And so when you want to find this one, you're gonna say that this Z is going to be inverse norm of And remember here, we're doing area to the left. So we're gonna do inverse norm of alpha over 2. So alpha over 2, which is
0.05.
z is equal to inverse norm of 0.05 divided by 2, right? So go ahead and plug that in and tell me what you get. 0.05 divided by 2. Let's get the calculator. Did you get an answer? There's okay, let me bring it up.
How many decimals are we rounding to this time?
Good question. Usually 2 for these. Usually 2 because they're z-scores. Let me see if
I got negative 0.67.
Okay, okay. So here's your screen. Can you see my calculator on screen?
No.
No. All right. How about this? Let's try that. How about now?
Yes.
Yeah? Okay. And let me change. Okay, and we're doing the plus. So I'm going to go to inverse norm right here. 0.05 divided by 2.
It says 0.0.
Thank you, Jason. 0.05 divided by 2. All right, my alpha here, paste it. What? I'm not sure why that happened like that, but let me clear a few things. I'm not sure why that's. I don't need my calculator to do funny things this morning. Okay. 0.05. Let's see if this works better. Does it? Let's see. Okay, I think so. I have negative 1.96.
But I put in the, oh, I forgot the 0.
Oh, you put 0.5 instead of.
Yes.
Okay. Remember, this is a two-tailed test. So my other value for this, I'm going to have 2 values, right? Is going to be, so this was my
96.
left side. My right side, I'll put it up here. My right side is going to be z is equal to inverse norm. This is going to be 1 minus alpha divided by 2, okay? Which is going to give me z equals inverse norm 1 minus 0.05
Oh, I put that.
divided by 2. You can put the whole thing in there. So this is going to be, let me go share the calculator and let's do it. This is going to be second distribution, inverse norm, and I'm going to put 1 minus 0.05 divided by 2. Paste it. And it's 1.96. I did that so you would see how to use the instructions. In 8.1 and 8.2, if you have 2 critical values, and you'll have 2 if they're two-tailed, if you have 2 critical values, they should be opposites like this, okay? 1.96. All right, let's do another one. Let's do B. B is alpha is 0.01 and it's left tail. Alpha is 0.01 left tail. So this means that you're doing, here I have a distribution. Let me draw it out. Here's my curve, right? This time I'm in the left tail, so I'm here. I only have one critical value, right? Is it going to be positive or negative here?
Let me see. It says negative. The alpha is 0.01.
Right. And so is it going to be positive or negative? What tail are we in, remember?
Positive?
Okay, but we're in the left tail.
Oh, negative.
So it's going to be negative. Yeah, left tail values are generally negative. So here we're going to have Z is equal to inverse norm alpha over 2. Okay. So it's just like before, except our alpha's changed. And we only have one of these. So now we get Z equal the inverse norm of 0.01 divided by 2. So let's do that and see what we get. We're going to get second distribution, inverse norm. We're going to say this is 0.01 divided by 2. Paste it. And we're going to report this as negative 2.58 because it's 575. I'm going to report that as Z equals negative 2.58. Okay.
Mm-hmm.
All right, next one. Next question says, part C, alpha equals 0.005 right tail, 0.005 right tail. So here we have here's my, now I'm over here in the right tail, okay? And this area here is 0.005. And I want to find this Z value, okay? So I'm going to say that Z is, what do you think, Jason? What are we going to say? No, inverse norm of what?
Of 0.005.
No, because this is in the right tail. So let's look back at this here. If it's in the right tail, it's inverse norm of 1 minus alpha.
Oh.
Okay, because we're not splitting it this time. So it's 1 minus alpha. So here, this is going to be, let me actually, let me do this first. Let me go over here. This is going to be, we're not splitting it. So this is just 1 minus my alpha. Okay. And it should be a positive number. So this is going to be 1 minus 0.005. That's going to be my inverse. So here I have second distribution. Let me clear this out. Second distribution. Inverse norm number 3. Here I have 1 minus 0.005. Paste it. And I have 2.58 again.
Okay.
Okay.
I got positive 2.58.
Yeah, it's positive.
I got a question.
Yes.
On B, is it negative 2.58 or negative 2.33?
Hold on. Let me check. Let me see. Did I? On B, you said?
Yes.
0.01 left tail. 0.1 left tail. It should be negative because it's a left tail. So let's see. 0.01 in the left tail is going to be, hold on. This is second distribution, inverse norm 3. And if we're doing left tail, we don't have to subtract from 1. We're just going to have 0.01.
Okay. I don't see the calculator.
No?
Mm-mm.
Okay, how about now?
Yes.
Yes? Okay. So this is my alpha for B, correct?
Mm-hmm.
And I don't subtract from 1, so I have this. Negative 2.33. I might have put an extra 0 in if I got a different answer the first time.
Nah, it's only divided by 2.
Oh, maybe if I thought it was 2 tails. Yeah, that could be. If it's a left tail, if it's a left or right, I don't divide by 2. If it's a 2 tail, then I divide by 2. Okay.
Okay.
Okay, are we good? So we're ready
Yep.
for D?
Mhm.
All right, let's do D. D says alpha is 0.01, but it's a right tail test. Now we just did a left tail a minute ago, okay? What would you expect to be the answer for the right tail here? E and D are the same except for the tail they're in.
Right-tailed?
So go ahead and do D. It's a right tail test. So here we're going to have second distribution, inverse norm, number 3. And this is going to be, since it's a right tail, we're going to do 1 minus 0.01. Okay.
That's it?
We don't split it because it's not a 2-tail test. Paste it, and we get, now what's the difference? B is, letter B was this middle one here. This was letter B up here.
Yeah.
And
It's
letter D
positive.
was down here. The only difference is the sign. Right?
Yep.
So 0.01 in the left tail, which was letter B, was negative 2.33. 0.01 in the right tail is positive 2.33. Okay. Just something to be pointed out when you're doing it. It's one way to kind of check your work as you go if you suspect you made a mistake somewhere. All right, letter E. Letter E says alpha is 0.05 left tail. So we don't have to split this. Alpha is 0.05 left tail. So here we're gonna do second distribution, inverse norm, and it's 0.05 in the left tail.
That's it?
We end up, yep. And we end up with negative 1.64. The answer key might say negative 1.65, and that's based on using the tables or the averaging method. If you use the calculator and you get 1.64, that's acceptable. If
I got it.
using something else, this is one of the cases where she'll accept either answer, depending on what you use, because we're aware of it, okay?
Yep.
All right, so we got that. So now let's go on to number 7. This is where we can explore the hypotheses a little bit more, okay? For each conjecture, state the null and the alternative hypotheses, okay? What she wants here is for you to write the pair with the symbol, okay? So let me give you an example of what she means here. This says, no, I don't want to do this just yet. Let me annotate on the screen. So this first statement, average age, right? What is our symbol for average? What is the symbol that we usually use for average?
Which page is that one?
It's number 7. What symbol, what Greek letter do we usually use? What's another name for average that we use?
Alpha?
No, we call it, starts with an M. Your grade point average is 1. The average score on your exam is 1. We call it the mean, right?
Oh.
What is our symbol for the mean?
U.
Right. So what we're going to write is we're going to write 2 statements for each one of these. So for A, we're going to write this. We're going to say, we're going to write our null, HO, and we're going to write our H1, okay? The average age of community college students is 24.6 years. Is 24.6. Is another name for equals. So that goes with our null hypothesis. This is, you would write mu equals 24.6. Okay, that's your null hypothesis. Now, your alternative hypothesis to that is that it's different from that. Doesn't say that, but your alternative is always the other option, okay? So she's going to give you one of the statements, either the null or the alternative, and you have to fill in, you have to write them both from what you're given. So if we know mu is 24.6, H1 is going to be mu is not equal to, it's different from, mu is not equal to 24.6. This is your alternative hypothesis. Okay, so there's two statements for each of those. Okay, 7a is mu, HO is mu is equal to 24.6. H1 is mu is not equal to that. Okay.
Mm-hmm.
7b is very similar. The average income of accountants is 51,497. So 7b is going to be HO mu
Wait.
equals.
Wait a second. Oh, it's the same ones, just
It's the same words, we just changed the story. That won't be true when we get to number 3, but it's, this is 497. And this is H1. H1 is mu is not equal to not equal to 51,000. $497. Any questions on those two?
no.
Okay, now C says the average age of attorneys, so mu, is greater than 25.4. So what do you think we would write for C?
The mean.
Okay, so you start HO
Mm-hmm.
and H1, right? Start with that. You're going to write the mean in both. That's correct. We're going to write the mean here. Let me put it over there. There we go. We're going to write mean here. And we're going to write mean below it. Now, the statement that's given to you in C, the average age of attorneys is greater than 25.4. Is that a null or is that an alternative hypothesis in C?
Alternative.
That's right. So you're going to write it under H1, okay?
Mm-hmm.
So this is going to be mu is greater than or equal to, I'm sorry, just greater than, mu is greater than 25.4, okay? When you go back to write the null, okay, what we're going to do is we're going to turn the statement around. So we're going to say this. We're going to write mu is less than or equal to. Because remember, the null always contains an equal. So mu is less than or equal to, and you're going to have the same number that you had in the statement, 25.4, okay? That's for
Okay.
C. So far, so good?
Yep.
Okay. Let me show you one quick thing because I wanted to wait till we got here to do it so that, and you've seen it already, but we didn't go over it yet. Let me just switch the screen share for a second and show you this. So if you want to look at the types of statements, if you look at her remarks on slides 10 and 11, okay, we just had a right tail test right now. Okay, if you look at the bottom of slide 10, it said the average age of accountants mu is greater, and K there was 25.4. This gives you the setup. So mu is greater, mu is less than or equal to K. Here, this means is equivalent to mu equals K. She wants you to write the version on the left here. But the reason she does this is that before she started giving the answer key will always tell you equals, always. But that messes it up with the two-tail test. So make sure you're using the left-hand portion, but she gives you the formats on slides 10 and 11. I just wanted to point that out because I didn't have a chance to make it clear earlier. All right, so here we are. We've done A, B, and C. Let's do D. The average score of high school basketball games is less than 88. Average score is less than 88. So here, what are we going to say?
What happened?
What are we going to do for letter D? The average score of high school basketball games is less than 88. Is that a null or an alternative hypothesis?
Alternative.
That's correct. So we're going to say for 7D, we're going to say this. We're going to say that HO, and we have H1 here. So this is mu is less than 88. Okay. That means HO is going to be mu and we're going to write is greater than equal to 88. Okay. All right.
Yes.
How about E?
Alternative.
Right. Correct. So the average resting pulse rate of male marathon runners is less than 70. So HO and HA or H1, sorry, is going to be mu is less than 70. And HO is going to be mu is
Greater or equal to.
greater than or equal to. All right, now the exercises in number 8 below that use some different phrases, but it's the same exercise, okay? They're just, the phrases are a little more, now that's why you have the common phrases in the front of your slides. I don't know if you noticed that, but let me show you that really quick too, so you can go through that. If you look at your slides, and this will be true about pretty much every section from here on, because these are so important. she gives you the first, these are for your reference, okay? But she gives you common phrases and she tells you how they translate, okay? So if you're not sure, you have them here. So everything that means greater than is listed. Everything that means less than is listed. Everything that means equal to is listed. Now, the ones that people tend to get the most stuck on are is less than or equal to. So is at most, is at least. These are given to you here, okay? So if you see at most, that translates to less than or equal to in the first column. If you see is at least, that's greater than equal to. These are some of the phrases that we're going to be working with below. We did a lot of the phrases on this first page with the first group. We're going to use some of the phrases in the second. You're going to see some of them, but you're going to see some phrases from this second page. So if you want to take advantage of that, it's there for you. Let me switch gears and go to the homework again. Okay, so 8A, let me bring up the screen here one more time. 8A says, the average age of first-year medical students is at least 27 years. At least 27. Which symbol and which hypothesis is that?
What was that?
Number 8A, right?
Mhm.
The average age of first-year medical students is at least 27. How would I translate? We know what average is. We know it's mu, right? How would I translate at least?
Great. Now, wait.
Uh-huh. Greater than or equal to. Very good. Yeah,
Okay.
because 27 is the least. So it's at least 27, right? So in this case, that's HO. You are correct, Jason. Very good.
Okay.
He's like, okay, I'm not sure, but that's good to know. All right, so HO here, this is gonna look like this. So we're gonna have, let me figure out.
You might want to share because I can only see the question sheet.
Yeah, no, I know. I'm getting there. I'm getting there. This is the questions, and what I'm wanting to do is annotate the screen. So, but it wasn't letting me do that right for a minute. Okay. HO is mu is greater than or equal to. So this is going to be greater than or equal to 27. Because it has an equal sign, it includes 27. It goes under HO, okay? Mu is greater than or equal to 27. My H1 is going to go the opposite direction. So H1 is going to be mu is less than 27. I don't need an equal to in my H1 ever. So here, this is going to be mu is less than 27. Okay, this is 8A right here. 8A. HO mu greater than or equal to 27. H1 mu less than 27. Okay. B, the average experience in seasons for an NBA player is 4.71. So 8B what am I gonna say for 8B?
Okay, I can't see it. The average experience in seasons for an NBA player is 4.71.
Okay, so what am I gonna write for mine?
Don't know.
Well, what does is mean? How does is translate if it's a symbol?
Greater or equal to?
Not here, just the word is. Just the word is. If I say the sum of 3 plus 2 is 5, right? How would I write that in math terms?
Is it statistical hypothesis?
It's a statistic, which one?
A statistical?
Okay, but I'm writing, what we're doing right now is writing statistical hypotheses, okay? And I need to know what symbol goes in here. Is means equal, right?
Oh,
Is means equals. So here, this is mu equals 4.71. Okay. And so underneath that, I would write, we did an equals up here in number 7. To look at A and B of number 7. It's very similar. Okay. Is
equal
means
slash?
right. We read that as not equal. Right. We read that as not equal to.
Okay.
So the other one would be not equal to 4.7. Okay.
Is
All
D
right.
the
How
same
about,
too?
what was that?
Is D the same also?
Yes. Mm-hmm. Mm-hmm.
So equal and not equal to.
Mm-hmm. And there's
Got it.
another one on here that's the same. Can you find another is?
E,
Yes. What is your mean there?
8.2.
Yes.
So
Yeah.
equal and non-equal to 8.2.
8.2, right. The thing that's sometimes tricky for people about letter E is I've seen people use 6 instead of 8.2 before. Because they're thinking about the number of weeks instead of, because it says weight loss, the average weight loss. So we want the pounds that go with the weight loss. So it
Okay.
is 8.2 versus not. Very good. Okay, so now which ones do we still need? We need C, right? We need
Oh,
C and just C, right?
I thought we did C. Oh, no, we didn't. We didn't do C.
8C. But it's not
Yeah.
that hard. See if you can try it. See if you think you can do that one. I'll help you if you need it. What do you think? The average number of monthly visits sessions on the internet by a person at home has increased from 36 in 2009.
Increase. It's less or greater. It's greater.
It's greater. An increase means it's larger, right? So that's going to be part of which hypothesis, the null or the alternative hypothesis?
Alternative.
That's right. So we're going to write HO and we're going to say H1 here, right? And this is mu is greater than, and it's increased from 36. So we're going to write 36 here. What is the null going to be?
U is less than or equal to
Less than or equal to. Very nice.
36.
Good job. Mu is less than or equal to 36. So this lesson is just designed to get you familiar with some of the individual pieces of hypothesis testing so that when we actually start doing the word problems that relate to it, you'll be able to put the pieces together. That takes some time, and that's why these lessons are so long. Once you get, I would say once you've done 8.2 and 8.3, maybe 8. By the time 8.4 rolls around, you should be feeling pretty good about it because you will have seen a lot of them, but it usually takes a couple of sections to start feeling good about things. So it takes a while to get that done. Okay. All right, Jason, good work today. I appreciate you being here.
Yeah, okay. Thanks for the help.
You're welcome. I'll see you soon, Jason.
Okay. I'll see you tomorrow.
Okay then.
Bye.
Bye.